Okay, let's revisit something we've done before, and that is, well, you tell me, what kind of equation is this? Quadratic, yes. So we start by thinking about it's quadratic, and we know that because we see the x squared. You can consider either the square root method, the quadratic formula, factoring, or completing the square. So because we haven't done the quadratic formula yet this term, you might have done it in previous classes. I hope you have. Who can remember what the quadratic formula is? Oops, negative b. Sorry, what did I write? X. X equals negative b plus or minus square root of b squared. All over 2a. Now you might know it to Pop Goes the Weasel. You know that one? X equals negative b plus or minus square root b squared minus 4ac all over 2a. So anyway, now you can have that as an earworm for the rest of the day. You're welcome. If we want to solve this using the quadratic formula, it has to be set up in what we call standard form. We were talking about this before. For standard form, you have y equals ax squared plus bx plus c. And in order to solve this using the quadratic formula, you have to set it equal to 0. So is this one set up yet in order? No. So what would you need to do in order to set it up in standard form? Yes, add the 1 to both sides. So we get x squared minus 3x plus 1 equals 0. That allows us to get our a, b, and c. A is equal to what? It's a coefficient of x squared. What's the number in front of x squared? 1. B is equal to negative 3. And c is equal to 1. And that's important because with that sign change, a lot of times people will forget to add the 1 to both sides, so they'll use a negative 1. That's going to give them the wrong answer. You don't want that. Don't do that. Don't do that, okay? So now, if we want to use the quadratic formula, we go x equals negative b, so that's negative, the opposite of negative 3 is 3 plus or minus the square root. That's going to be negative, or that's going to be b squared. So I'm going to square all of negative 3, and what do I get if I square that? 9 minus 4 times a, which is 1, times c, which is 1, all over 2 times a, which is just 2. 2 times 1 is 2. Okay, now we simplify, and we get 3 plus or minus the square root of 5 over 2. Does everybody see where I got 5 from? And 5 is not a perfect square, so this is the answer. You have two different answers, 3 plus the square root of 5 over 2, and 3 minus the square root of 5 over 2. Those are our two solutions, and what I'm going to show you in a minute is how you might be able to check that on using Desmos. I did want to show you how this would work. That's the quadratic formula, okay, this method. I do want to show the completing the square. We actually already learned this, so maybe you already know how to complete the square, and if you do, you might stop the video right now and try it, okay? But if I want to complete the square, I go x squared minus 3x, and I'm going to leave a spot for a plus over here, equals negative 1 plus the same thing, right? I'm going to add the same thing to both sides. And now I'm just realizing, oh, this one's going to be a little funky because there's going to be a fraction. That's okay. We'll do it with a fraction. All right, what would I do to complete the square? I have to take half of negative 3, which is what? 3 halves. So we end up, if we factor it, we get x minus 3 halves. And if I square that, don't I get 9/4? So I'm going to add 9/4 to both sides. That factors, right? So the whole reason why we did that is so that we could factor it this way. Now, if I have this, what do I have to do in order to add a fraction to a whole number? Isn't this the same thing as negative 4 over 4? What's negative 4 over 4 plus 9 over 4? Yeah, it's actually a positive 5 over 4, right? Because you have more positive than negative. Okay, now what should I do? I can use the square root method. Because I have the square isolated, I can use the square root method. So the square root method means I'm going to take the square root of both sides. I have x minus 3/2 equals plus or minus square root of 5 over what? What's the square root of 4? 2. Does everybody see where I got the 2, why I was simplified? That's the square root of 4 is 2, right? So I took the square root of the numerator denominator. I can't take the square root of 5 because it's not a perfect square. It's irrational. So now what should I do to get x by itself? Yes, add 3/2 to both sides. So I get x equals 3 plus or minus the square root of 5 over 2. Same thing, right? I just use the fact that they have a common denominator to put them under the same. That's the same thing as 3 plus or minus square root of 5. You could have them both over 2. It's the same thing, right? I'm just dividing 2 into both, but if I have a common denominator, I can add or subtract the numerators. Now, if I wanted to check this using my Desmos, let's see, I could type in one side and then the other side. So I'm going to type in on one side, I'm going to type in x squared minus 3x, x squared, oops, that's not x squared. This is why I said I like to do them in advance. X squared minus 3x on one side. So I could write y equals, or it's just showing that parabola. And then where is this equal to -1? So I'm setting it equal to the other side, -1. And I'll actually, this one I will go y equals. Y equals -1. And you can see those 2 points of intersection. Now, the thing is when I click on those points of intersection, it's actually giving me decimal values. How am I going to know that this decimal value is equal to this? How do I know if I did it right? Well, Desmos is also a calculator. So if I plug in 3, oops, go backwards, parentheses, 3, because this whole thing needs to be grouped. And I can't do, these are two separate answers, so I can't do it all at once. If I do x plus the square root of 5, close my parentheses, oops, go back, out, 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 there we go. Close the parentheses, now divide by 2. You see what it's doing here? It's giving me the decimal equivalent. So the positive one is approximately 2.61. Oops, and I wrote 3.1. I don't know why I did that. 2.61 or 2.62. And if I click on that point, you can you see that the x value is the same? If I do that same thing, but I take out the negative or I take out the positive, I use the negative, I get 0.381. Well, I would round that off to 2, but if I click on that point of intersection, it's rounded. Oh, it's rounded appropriately. It's rounded to 2. Okay, so that would be a way that you could use these ones are a little bit trickier to check. I mean, of course you can plug it back in, to your original, but I think that once you get into this irrational territory, your Desmos is not going to give you we call this the exact solution versus the approximate solution, right? The approximate means that it's not exact. When you take the square root of 5, you get a decimal that goes on for infinity. And that's why whenever you round it off, you're not getting the exact anymore. You're getting an approximate. Does that kind of make sense? That's what I would do with these to check them. So let's have you guys try a few of these examples. You have several problems to try, so you can go back to, or you can start with example 3, try some of those problems, and then example 4, 5, 6, Yeah. Well, actually, we'll do another completing the square in just a moment. So try some of those, and then we'll come back together.